So today's lesson, we're going to talk about factoring polynomials. In the last few videos, you practiced multiplying polynomials using the FOIL method, multiplying the first, outer, inner, and last. But now we're going to talk about what it means to factor those polynomials. So I want you all to write down these first two examples and to multiply them. And tell me what you get. So the first one is 20x squared. And the second one is also 20x squared. So here we have our products. Or a product. And then for number one, the factors of the product would be 4x and 5x. So the numbers that I multiply together to get the product. And then for number two, we have different factors, but notice how when you multiply those two, you also get the same product. So factoring is undoing that multiplication. So there are multiple factor pairs that we can find for 20x squared. For instance, we can use our numbers 1 and 2, or I can say, all right, how about 5x squared and 4? Those are factors of 20x squared. Or I can say 4x squared and 5. Those are factor pairs of 20x squared. And there's quite a bit of variety that you can use. So we have a bunch of factor pairs here. And so this is going to be useful when we begin factoring using the greatest common factor method or the GCF method. So we had 20x squared. We said that 4x and 5x are factors of the expression, or we said 2x and 10x are factors of the expression. And so factoring is the reverse of multiplication. Okay. And so two-factor means to write an equivalent expression that is a product of two or more expressions. So that when we are factoring, we are actually doing the reverse of multiplication and writing an equivalent expression that is a product of two or more expressions. Okay. So now we're going to practice all these different methods of factoring. There are going to be quite a variety, and that's what this unit will be. So today we're going to focus on factoring out the greatest common factor. So for this first example, I want you to write this down, 5 times x plus 3, and I want you to multiply. So when we distribute, I hope you all got 5x plus 15. So 5x plus 15 is the product. And the factors of this expression are 5 and x plus 3. Those are the two things we multiplied in order to get the product. So when we begin factoring, we want to talk about factoring out the greatest common factor. So when we look at this first expression, is this a monomial, binomial, or trinomial? So this is a binomial. We have two terms, the 5x and then the 15. So look at 5x and look at 15. What is the greatest common factor between 5x and 15? So there's only an x here, so x can't be part of the greatest common factor. But notice how you have 5 and you have 15. So the greatest common factor is 5. So when we factor out a 5 is what we're going to do. we're factoring out a 5, so we're undoing the multiplication. So if we factored out a 5 and undid the multiplication between 5 and x, we'd be left with an x inside of those parentheses. If we unmultiplied 15 by 5, we'd be left with 3. So when we factor 5x plus 15, we get 5x, 5 times x plus 3. So that's how we factor out a GCF. So factor each expression by factoring out the greatest common factor, or the GCF. So if we look at this, ask yourself if it's a binomial, trinomial, or monomial. And we have a binomial here. So looking at this first term, we have 3x squared. The second term, we have a 3. So what is the greatest common factor between 3x squared and 3? And if you said 3, you are correct. So if I undid the multiplication, so factoring is undoing the multiplication or undoing the distributive property, we'd be left with another binomial. So when we divide 3x squared by 3, we get x squared. When we divide or undo multiplication by 3 here, we're left with 1. So we know that 3 and x squared plus 1 are factors of the expression. A way for us to check to make sure that we factored correctly would be to do what with this expression? We remultiply, then we can check to make sure that we factored out carefully. Okay. And if we distributed this 3, we need to get back to the original problem in order to check. Okay, so I want you to write down these two problems, pause the video, and then see how you do, but make sure that you're looking at each term and finding the greatest common factor. So for this first one, we want to find the greatest common factor in this binomial. So we have 5y to the 4th and then 20y to the 3rd. So look at the numbers first. So ask yourself, okay, between 5 and 20, what's the greatest common factor? So the greatest common factor is 5. And then between y to the 4th and y to the 3rd, the greatest common factor is y to the 3rd. So when we factor that out, we are left with what term in this first expression? We have 5y to the 4th. We factor out a 5y to the 3rd, so we're left with just y. Because if we remultiplied that, we get back to the original. And then we have that minus. And since we factored out a 5, we're left with 4. And since we factored out a y to the 3rd, we're done. So 5y to the 3rd, and then y to the y minus 4 are our factors. So we have fully factored this expression. Looking at the second expression, let's look at the numbers first. So we have 16 and 20. So the greatest common factor. So you could say 2 is a factor of both 16 and 20, but we want to look for the greatest. We can say, let's see, would 4 be the greatest common factor? Yep, I think 4 it is. So we have 4 as the greatest common factor between the numbers. And now let's look at the letters. So we have a squared here and a squared here. So that's common. So we can factor that out altogether. And then we only have a b squared in this term. So this is just going to stay. So we'll set up a parentheses because we're going to be having a binomial in this parentheses. So if we factor out a 4, we'd be left with 4. And we factor out an a squared, so there's nothing here. But we'll be left with 4b squared plus 5. So 4a squared and then 4b squared plus 5 are the factors. We've factored everything out fully. Okay, let's write down these next two problems and pause the video and see how you do factoring out the greatest common factor. Okay, for the first one, we have a binomial. So we have 4x and then 9y. Is there a greatest common factor between 4 and 9? No. So if we can't find the greatest common factor, and then notice how this is x and this is y, there is no greatest common factor. So a number that we cannot factor we call prime. So this is a prime polynomial. An expression that cannot be factored. So we have to ask ourselves, if we're asked to factor, we may have things that cannot factor, so we can call it prime. You don't have to say prime polynomial, but you can just say, oh, this is prime. Okay, for the next one, we have a trinomial. So notice how we have a 2 here, but we don't have any other numbers. So 2 is not part of the GCF, the greatest common factor. But we have p to the third, p squared, and p. So the greatest common factor would be p. And now let's look at the q's. Q squared, q, and q. So the greatest common factor is just q. So since we have a trinomial and we're factoring out the greatest common factor, we're going to be left with the trinomial in these parentheses. So we have 2p squared q plus p plus, since we factored out a pq, we divide pq by pq, we are left with 1. And notice how if we were to remultiply this, we'll get back to our original problem. So those are our factors.